Welcome to the Explainer. Today, we're going to do something a little different. We are literally going to put on an examiner's hat and deconstruct a real GCSE chemistry question. We'll show you not just how to answer it, but how to lock in every single one of those valuable marks.
So, what you're seeing right here is part of a real exam paper. We're going to dissect this question on electrolysis, and we're going to use the official mark scheme as our roadmap. By the time we're done, you won't just know the right answers, you'll get why they're the right answers. And trust me, that's the real key to understanding this stuff.
All right, let's get right into it. Our focus is question 06. Now this one is brilliant because it actually covers two different scenarios for the electrolysis of sodium chloride, and it's really testing whether you can spot the critical differences between them.
So, first up, we're diving into the world of molten electrolysis. This is where we're dealing with sodium chloride that's been heated up so much it's melted into a liquid. The most important thing to get your head around here is that there's absolutely zero water involved. None.
Okay, so the first part here for 1 mark is a multiple choice question about a half equation. Remember, a half equation just zooms in on what's happening at one of the electrodes. In this case, we need the one that shows how a sodium ion becomes a sodium atom. And boom, here's the answer, right from the official mark scheme. It's a positive sodium ion plus an electron, giving you a neutral sodium atom. This all happens at the negative electrode, the cathode. See, that positive sodium ion gets pulled towards it. It grabs an electron. We call that reduction, by the way, and just like that, it becomes a sodium atom. All right, moving on. Question 6.2. It's pointing out this mesh that's separating the electrodes, and it's asking a pretty simple but super important question. Why is that mesh there? Why do we need to keep the products, the sodium and the chlorine, apart from each other?
So the mark scheme is crystal clear on this one. It's all about stopping the products from reacting with each other. And it makes total sense, right? You've got super reactive sodium metal and this reactive chlorine gas. If you just let them mix together while they're hot, they just react like crazy and you'd be right back where you started with sodium chloride. All that work for nothing.
So the next question is, what's actually moving through that mesh? I mean, for the whole electrical circuit to even work, something charged has to be able to move between the electrodes to carry the current. So, what is it?
And the magic word that gets you the mark is ion. Yep, it's those sodium ions and chloride ions floating around in the molten liquid. They're the ones that are free to move, carry that charge, and keep the electricity flowing. Simple as that.
Okay, let's switch gears to the second part of the question. This is where things get a bit more interesting, because now, instead of molten salt, we're dealing with an aqueous solution of sodium chloride. And that means one thing: water is now in the mix. And believe me, that changes everything.
And yep, that's exactly what question 6.4 is all about. We've still got our sodium and chloride ions from the salt, but because we're in water, 2 brand new ions show up to the party. For 2 marks, you've got to name both of these newcomers.
And here they are, straight from the water itself. Hydrogen ions, H+, and hydroxide ions, OH-. And a little tip, the mark scheme is happy with either their names or their formulas, so use whichever you're more comfortable with. They both come from a tiny amount of water molecules that naturally split apart.
So now we've got a party of 4 ions floating around in there: sodium, chloride, hydrogen, and hydroxide. And after all the reactions at the electrodes are done, we're left with a specific alkaline solution. The question is, what is it?
The answer is sodium hydroxide. And here's another great exam tip right from the mark scheme. You can write the name out in full, or if you're feeling confident with your formulas, you can just pop down NaOH. Either one gets you the mark. Examiners love it when you're efficient.
All right, here we go. The big one, question 6.6. This is a 3-marker. Now, these longer questions are where you can really show off what you know and pull ahead of the pack. With these, it's not enough to just say what happens. You've got to explain how and why.
So the 3-mark question is, how do you get all the points? You have to explain how that alkaline solution, sodium hydroxide, actually gets made. And look, the question itself gives you a massive clue. It says you must talk about what's happening at the electrodes.
This is awesome. The mark scheme literally breaks it down into a 3-step checklist to get your marks. First, you just have to say which ions are left over to make the sodium hydroxide. Second, and this is the real aha moment of aqueous electrolysis, you explain what happens at the negative electrode. Because hydrogen is less reactive than sodium, it's the hydrogen ions that get discharged, not the sodium. And third, you explain what's going on at the positive electrode.
And check this out. This is such a good bit of exam strategy to know. The mark scheme gives you options. For those second and third points, you don't have to use those specific fancy words like discharged or oxidized. You can still get the marks just by describing the electrons, saying that hydrogen ions gain electrons and chloride ions lose them. Or even better, if you're confident, you can just write out the correct half equations. Job done.
Okay, so let's zoom out for a second. What has breaking down this one question really taught us about exam technique? It's shown us that it's not just about knowing the science, right? It's about how you communicate that knowledge with total precision. And this is exactly why this stuff matters. Using those precise scientific terms, being confident with your half equations, and learning how to structure your answers for those bigger multi-mark questions, these are the skills that really show an examiner you know your stuff. It's what separates a pretty good answer from a perfect score answer. So if you take this same approach, this kind of deconstruction method, to your own revision, you can start to see exam questions not as these scary obstacles, but as puzzles where you know exactly how to collect all the points. You're basically learning to speak the examiner's language, and that can turn even the trickiest questions into marks you can count on.